word real, and you're trying to solve this. So what type of an alert does that raise when you see the word real? Anyone? Yes, sir.
No imaginary numbers.
No, tell me again?
No imaginary numbers.
No imaginary numbers. No imaginary numbers. If I'm not mistaken, and I don't have the handout right in front of me there, I think the next part of that handout was asking you to find what is, have a different phrasing? Or am I thinking about the right one? Was there another part coming up later? Did they say find out what?
Complex.
Complex zeros. Now that allows you to bring the I in, the imaginary unit. And I know some textbooks will just phrase it, find the zeros. They won't specify real or complex, so they want you to find everything. In fact, they're asking you to find complex. Okay, so guys, we'll focus on complex zeros, see what that's all about, the I coming up. I'll try to finish this handout up. I've got a couple more handouts coming out. By the way, are these handouts helping? Whew. Okay, so I'm condensing the sections from the textbook to give you an idea of what's going on here. Okay, guys, before I jump into it again, any quick questions? June, Mr. Park, anything to say before I jump into it?
I also have review sessions today from 3:30 to 4:30.
So she's got a review session 3:30, 4:30 in the math lab?
Yeah, in MCAD 4B.
She's always here. She's always here. Okay? So please, for goodness sakes, I know it's a 6-week course, it's moving faster and moving faster. I want every student to get through this. Now I realize sometimes things will happen in your life. Things will happen in my life too, it happens in all our lives. That somehow will give us a setback. We might not be able to quite do it, but let's hope we get through everything. Let's hope we get through this course. Okay? Part 1, guys, for that handout I keep referring to. And check and see if I have it here. Yeah, 2.3. Remind me, PK, are you the one where we were trying to find 6 zeros? And we had to go into something called the difference of cubes and the sum of cubes formula, right? You guys recall that? And I gave you the formula. Now, I realize you've got enough to worry about besides just standard formulas. So more than likely, if I give you something on the exam that requires something like that, I would probably have on the side the formula. So I'd probably write the A cubed minus B cubed formula. Might be helpful here. Something to that effect just to help you. Now remind me guys, did I finish up part 1 there, or 2.3? Did we finish up 2.3 altogether?
Yeah.
I think we did, didn't we? Yeah. Well, you just let you be something. So expect tomorrow, if you see one of these, and I'll have on the side just like here, let you be something. So it'll indicate to you to rewrite it and go from there. Now the next part, complex zeros. Here we go. Part 1. Let's start out with this. Let me first start out with this before I jump into the zeros. What on earth is a complex number? And one of my students in one of my classes not too long ago, I asked the class, what is a complex number? And his response was, Professor, all numbers are complex to me. I said, whoa. He meant to just, I guess he was trying to tell me math was a little difficult for him, a little hard. All my numbers are complex. No, I need a definition for it. Did I place the definition on that particular handout? I don't think I did I?
You did.
Oh, did I? Did I call it A plus BI?
Yeah.
Okay, so on the side here, if I can make a number look like this, and I better specify here the A and the B are supposed to be real numbers. And of course, we know the I, guys, should be square root -1. So if I make a number look like that, with those restrictions, A and B are real numbers, and then that I is a square root -1, that opens it up for imaginary numbers now. So if I can make the number look like that, it's known as a complex number. Before I jump into the exercises from the handout, please tell me, would this, even though it looks strange, would that be identified as a complex number? Does it look like the definition? In this case, what? A is 2 and B is what? 3. And then I have the I there. So definitely that's a complex number. If I saw this, would I identify that from the definition A plus BI? Does that take that form A plus BI? Are the A and the B real numbers? A, I think I threw in a square root 3. That is a real number. And then negative 10 definitely is a real number. And the I. Now what may throw you though is, suppose I ask, is that number 6? Should I consider that as a complex number? We should. Because the way professor doesn't look like A plus BI to me. Could I easily rewrite this as that? Is that still 6? 6 plus 0i, and the restriction was just make sure the A and the B are real numbers. Well, 6 and 0 are real numbers, and I threw the I in. So yes, that can be identified as a complex number. Therefore, all these real numbers from elementary school, the teacher back then didn't tell you, but those are basic numbers, were also, it could be identified as complex numbers. So guys, right now, the point in your math that you're studying, would any number be considered complex at this point? Unless you're going to another realm of numbers somewhere. Is that true, guys? Everything you think of could be rewritten in this form, A plus BI. Therefore, that's what this is all about, and I think from there, I may have asked you to solve a few of these, or to get some complex numbers as zeros. You know, the first one looks like this. F of x is equal to x squared plus 4x plus 8. Now, I'll tell you ahead of time, you guys who are strong at factoring, I think some of my students are getting stronger at factoring here. It's not going to factor. I would not use completion of the square. You could. Some students are good with completion of the square. And the other method is what? Quadratic formula, since this is a quadratic. So I need to solve this by quadratic formula, no problem. That would be x equal to, by the way, guys, that's when you set this equal to 0. Okay, x is equal to a negative 4 plus minus square root, I'll do it quickly. I'll get a 16 there, that's b squared. Subtract 4 times 1 times 8. I'll put those in. All over 2 times 1 is 2. Let's place numbers into that standard quadratic formula we all know. X is equal to negative 4 plus minus. Now here, be very careful. I'd like to know what is that radicand, or the part underneath there going to give me in this case. Begin. I heard minus 16. She sees the 16 here, then she says, wait, professor, on the end is this. And that product, negative 4 times 1 times 8 is negative 32. So 16 subtract 32, 16 plus negative 32, she says you got a negative 16 here. Still over 2. Now, if this was class yesterday, I'd say stop. No solution. Just stop and move on. We say no solution from yesterday's class. Today's class, though, with this, we go further. Now, how am I going to go further? We'll write this negative 4 plus minus. Guys, that square root negative 16 in the complex number system can be dealt with. Some students may know exactly what that's going to turn into if I bring in the I. Does anyone know right now what that looks like? I know square root 16 is a 4. Is that right there also going to be brought in? So what is that all together? Can I call it 4i? All over 2, and then reduce this down by 2. That's a negative 2 plus minus 2i. How many solutions did I get, by the way? I'm going to separate them. How many solutions did I get in this complex number system? I got 2. I should get 2. This is a quadratic. So guys, right now I'm gonna place these in a set. We'll separate them. -2 plus 2i. -2 minus 2i. Do you guys agree? We're done. That's it. We found the zeros for that first exercise there with the complex numbers open. Now, keep in mind, if on the exam tomorrow you see the word find the real zeros, what would I have to do here? Yeah, I'd have to stop and say no solution. There are no real zeros. If I open it up to complex where the I comes in, I can finish it up. Okay? Letter C, PK, if I'm not mistaken, I think we're running from the you and I class we were talking about yesterday. Next one looks like this from your handout. G of x is equal to x to the 6 subtract 9x cubed plus 8. May not be exactly the same problem, but I think it's going to be the same issue. Looks like that. Now notice on the side there I said let u be something. And I'll do that for you on the exam. Look, well, you guys, how many zeros am I expecting? That's 6. Now, I have no choice. If I say find these in the complex number system, which we're doing here, complex numbers, I have no choice. I've got to find all 6. I've got to show all 6. If I say just find the real zeros, I think yesterday in class, I think we could just find a couple of them. And then we had to turn something else. I think 2 of them came out to be real numbers yesterday. Guys, what am I going to let the u be? Usually, it's that in the middle. Which in this case, what, x cubed? And to make sure it is, I'd say, well, hold on, Professor. X to the 6 could be expressed like this from basic algebra. So it said, for the u there, so this becomes u squared, subtract 9u plus 8. I love this u substitution process. Look how easy that made that problem. It's now turned into a quadratic. That quadratic will factor, easily factored, or you guys could use quadratic formula on it. Split this up, and guys, at this point, I'm considering these. Now be careful, if you use the u substitution, you got to keep in mind u is representing x cubed, so they want you to solve for x. We're not quite finished. So it says x cubed is equal to 8. X cubed is equal to 1. Now please tell me, is this the same problem that we may have seen or much like it yesterday? Okay. Now, common sense tells me this is 2. This tells me it's 1. Is that true? 2 cubed is 8, 1 cubed is 1. So those are real numbers. If the direction says find the real zeros, they call them zeros, you're done. You don't have to find the other 4. But if I say on the exam, which I will say, find the complex zeros or find all zeros, you've got to find the other 4. Guys, there's 4 missing here. I need to find them. And now PK, it's a mathematician. Tell the class what on earth we did here on x cubed equal to 8 to maybe play around with it and try to get those remaining zeros. Okay, first I'll move the 8 over, right? And she says, Professor, as soon as you move that 8 over, right here, there you go. It's the difference of 2 cubes. I'm writing as a cubed subtract b cubed. And you've got to know, unless I'm feeling pretty good when I construct the test, I'll probably give the formula to you. But if I don't feel too good, forget it. You've got to know the formula on your own. So you guys are hoping I feel good when I construct the test? Yes, please, Professor, come on. Give me the formula. Is this a subtract b? Okay, got me on.
Yeah, a subtract b, a squared plus ab plus b squared.
There the formula is. Now, since she gave that to me, we're not going to check. That's amazing. that if you, from across the street, you were in that middle school across the street, they could do this. And the teacher asked them in the middle school to multiply these two together. It may take a little time, but multiply these two together, you'll get this. You multiply these two together, maybe a little lengthy, but a lot of those terms will cancel out in that process. You'll get a cubed minus b cubed. Now she wants me to apply that. PK, before we show the class how to apply it, I need to know what on earth is the a they're talking about, and what's the b in this formula. In my problem in the black. X here, and what's the b? 2. And why 2?
2 cubed is 8.
There you go, right here it is. That's the part right there. 2 cubed is equal to 8, and that's what they're talking about here, difference of cubes. And since I now identify the a and the b, it's easy. Let's write this, guys, as x subtract 2. Let's finish it up. X squared. It says multiply these two together, a times b. She's already identified the a and b for me, so it's 2x. Square the b, we identified the b as a 2. 2 squared is 4, and we have that. Is that true? Is that difference of cubes? Okay. Now, if I split this up, set this equal to 0, because we're looking for the answers, I'm going to get 2 here, of course. Well, we got 2 earlier. Let's just repeat it. This, though, it will give me 2 more answers, because that's a quadratic. Let me apply the quadratic formula to that. It's not going to factor, and see what happens here. Okay, so I apply the formula, x is equal to -2 plus minus square root b squared, 2 squared is 4. Subtract 4 times, and we put our replacements in, a 1 and a 4. All over 2, 2 times 1. Quadratic formula, we all know. Clean this up. X is equal to -2 plus minus. Can someone please tell me what on earth is underneath there? Tell me again. I think it's -12. Is it? Is it 4 subtract 16? Is there a 16 on the end? Is that a -12? All over 2. Now, if I was back on in yesterday's class, I said find the real zeros, we'd stop and say, Professor, I can't do any more. Please accept these 2 answers up here and move on. Leave the other 4 out. No, I want the complex. I gotta finish this up. So guys, it's gonna be -2 plus minus, make sure you can see the board here. Now, can anyone tell me what square root -12, bringing the I in, simplified, looks like? Go for it.
Would it be 2i square root 3?
Love it. Love it. That's still all over 2 if I have no mistake. And these guys will reduce down by 2. So we end up with a -1 plus minus I radical 3. Woo! At this stage, how many zeros have I done? I'm looking for 6. I've already done 4. We know 4 of the zeros. There's 2 missing. Okay, guys, the 2 missing. Oh my goodness, let me find where I am. Here we go. I mean, this can get tricky. If I now turn my attention to this side, PK, with this way it looks, could I move that 1 over and think of that right there as I did the other side? Think of it as looking like that. And apply the same formula, a cubed minus b cubed. That's not going to be the same formula here. And guys, you saw what I did on that last one, so let's do this one a little faster. Formula, of course, is this. Let's put our replacements in here, guys. This is for x cubed minus 1. Please tell me, it's x subtract 1, slow me down at any point. X squared plus x plus 1. And let me sit back and look at it. Do you guys agree? Is that true? Did I put the numbers incorrect? Applying the formula. split this up. I'll squeeze in right there, I'm running to my other problem here. Yeah, that one's gonna come out again, we had it earlier, let's repeat it. This, I'll put it on the side here. If I have no mistake, and please watch out for mistakes here, being on top of the board here, I need to apply the quadratic formula again. Here we go. X is equal to -1 plus minus square root b squared will give you a 1. Subtract 4 times a times c all over 2. And it looks like it's -1 plus minus. If you take a close look at that, I think it's square root -3 all over 2. Mr. Park, June, watch carefully because I'm doing this a little quick. I don't want to make any mistakes here. Guys, square root -3, what can I do with it? I don't think there's not much I can do with it. Can I bring the I in though? And rewrite this as -1 plus minus I radical 3 to show I'm in the imaginary number system? Is that true? Now you guys who've been watching, I didn't make a mistake, did I? If so, I'll go back and get that. Are those the zeros? There's a lot going on there. Now, here we go. Andrew. Guy, help me out. I do have 6 zeros. Start naming those 6 for us. And I'll place them in a step.
8, 2,
Back to it. Hold on. What's the first one?
8.
Not 8. That's the U. I'm looking for the X.
Oh, so like the imaginary number?
Now, the other one, we should get 6. Where are we?
2, 1,
Yeah, 2. There you go. Start 2.
2. Oh.
1. Now, what would the others look like? It's all scattered about. Did we finally end up with 2 more here? Okay, now I'll speak those. And did we end up with 2 more somewhere else? My goodness, where are they? Oh, up here. Were these 2 more? We got 2 here and 2 here. I think, don't we?
Here.
Okay, so that's 4 more. So if I separate those, let me separate those at the bottom first. They look better. -1 plus I square root 3. -1 minus I square root 3. There's 4. You guys are saying, Professor, all on the board here. There's the other one. -1 plus I square root 3 over 2, I think it was. -1 minus I square root 3 over 2. Let me close that up. If I count, I should have 6 in there. I think I do, don't I? That's when we have all 6 zeros. Jeez. Now, could you do one like that for me tomorrow? Shake your head, shake it. Professor, no. I'll see you in the spring. I'll see you in the spring semester. No, you're not going to see me in the spring. We're going to move on to Math 7 in the spring. Okay, so be aware of, though, if this happens, you gotta do it. Big help. We've got to find those 6 zeros. Now, guys, what's that? I'm checking myself here. I think, check. The other, I think, let me check and check. Let me see, X to the 6. I did have one more, didn't I there? P of X, was it? Okay. It looks like I'm finding the complex zeros for that one also, right? And that's much more doable than the one we just finished up. You're hoping you're not going to sit down tomorrow and open that test up and see staring at you, where am I? Not find here. Oh yeah, staring at you a 10 or an 8. Good luck. That means you can't walk out of here until you show me 10 answers. They call them zeros, 10 zeros. 8 zeros. Here mine was 6, I got 6 zeros. You're searching for those zeros. Okay. Now, it looks like on this particular exam, though, I can't go beyond 6. I created one myself. Guys, that last one, this is on your handout. I don't want to leave it out. We'll call this part D. Squeeze it up here. Looks like it's much more doable than the one we just finished. says find the complex zeros, and looks like it's a P of X equals this. X squared subtract 4x plus 1. Now this is what you'd like to see. That's what you'd like to see on the test. And I'll tell you ahead of time, it's not going to factor. So we jump into the quadratic formula. It is quadratic already. So no U needed here. So X is equal to, by quadratic formula, guys, that's a negative B. Well, I'll start out with a positive 4. When I use quadratic formula, I'll start out with a positive 4. It says negative B, where B is a negative 4. And I'm going to start out with that. Square root 16, subtract 4. Let's put the A and the C in. All over 2. Yes or no? Did I put the numbers in correctly? Quadratic formula? Watch carefully. X is equal to 4 plus minus, underneath there, I think is 16 subtract 4. Is it true? Which is 12. All over 2. And I said, Professor, why on earth did you, if I didn't make a mistake here, why did you bring this in? This one's not going to have an eye. This is more with what they're doing across the street. I don't think I see an eye come in. Do you guys? Unless I made a mistake, there's no negative there, is it? Okay, but can I finish it up? Of course I'm going to finish it up. So this is equal to 4 plus minus radical 12, guys, 2 radical 3 all over 2. Radical 12 can be simplified. Reduce everything down by a 2, no problem. And you're going to end up with 2 plus minus radical 3. Now, I had this in the category on your handout, find the complex zeros. May I accept those as complex, even though there's no I showing up? Is that true? Well, of course we can. We did this back here. That's why I brought this in. 6. It's a complex number. Has no I in it, but it can be written like this. And match up with this form here. Definition for a complex number. Of course I can consider these as complex. I know they're real also. So guys, if I separate them, we've got 2 plus radical 3, 2 minus radical 3. And we're done. I don't think my student will go wrong on this. I don't think so. I don't think my student will mess up on this at all. It may be a little bit of a challenge if I do go up to on the exam, even up to a 6. That's going to take a little time. See what all I had to do here? That would take a little bit of time if I go up to X to the 6. But the process is the same here. Yes?
Do you always let U equal x cubed so it can go with the formula?
Beautiful. It depends on what this term right here is. I did x cubed here. Andrew, good question here. Class, tell me what would I let you be if this had been not this, but this. Then what would you be? X to the 4th. Why? Why, if it were an 8, x to the 8th, why am I choosing now not x cubed, but x to the 4th? Why? Because back here, as we did here, that now is x to the 4th squared. That's x to the 8th.
But then how do you use it?
Beautiful. We have, good question. You said, wait, Professor, hold on. Do we have an x to the 4th formula like PK gave me for x cubed? No, I have to do really something that you can deal with. I see what you're thinking. Good. You said, wait, Professor, do we have a formula like PK gave you here in the green for a cube? And this one here was for a cube. Is there a standard formula for a 4? It might be, but no. We're not going to look at that. That would make it easier for you. Is that what you were worried about?
Well, how do you get the 4 to fit the formula though?
Oh, no, you can't use this formula. This is only for cubes.
Okay.
I'm saying there probably is a formula out there. You go to AI, and AI will show you anything. Sometimes they show you anything wrong. It'll find it for you. No, I'm not gonna give you that.
That's only the pi
Yeah,
complex number of square
For
footage.
cubes.
Okay. See, that's-
Don't go for the extra report. Okay, guys, I'm finished with that, took a little board space, but I had to get it done. Now, in this handout, we're getting to one part of this that I really get excited about. Oh, yes, we are right now. Before I jump into section 2.4, this is where I get to make connections for you. There's no need for you to sit there and think about math as, I know how some students do. They'll have math one day, and then all of a sudden the next day, there's no connection to what you did yesterday. Then all of a sudden the next day, there's no connection to what you did before. There should be a connection. And I try my best when I teach, I try to make a connection to something you've done before. I'm not gonna treat these as separate things, items, makes no sense. It's all related. And I'm talking about now in part 2, I guess it is, this. First, I'd like to sketch, with your help. I brought in a function before I get back to that handout. We're gonna start seeing some nice connections here. I've got f of x, a function, equals negative, and then I brought in x plus 4 squared, subtract 6. By the way, would you guys identify this as, the way it looks right now, would you identify it as a quadratic? Yes, it's a quadratic. If you expand this thing out and clean it up, it's a quadratic. I want to see a sketch. Now, someone remind me, what should a quadratic always sketch into? Unless something strange is happening to it. A parabola. Is that true? And then some students were telling me even yesterday, they said, Professor, I sort of remember you can look at this and tell when you go to the graph, whether the parabola opens up, does it open down? Is that true, guys? That's something we have seen before, and then from there we'll do other things here. I'm gonna put at the top here, we're gonna do this. I want to sketch this though, doing this. There's my connection to yesterday. I'm going to sketch it, not just by looking at it, I'm going to sketch it by using transformations. And some students may thought, oh, we had transformations yesterday, so we should not see transformations again? Oh no, everything's connected here. Now we'll sketch it, but someone's going to help me, I'll use different colors here, as to what is going on here, what types of transformations. Does anyone recall what this might be telling me to do when I finally start? Reflect, now reflect where? Across the x-axis. Don't confuse it with the y-axis, because this is a reflection through the x-axis. And when you see one of these on the, see a transformation problem on the exam tomorrow, which you will, I'll ask you to specify what they are. I'm going to ask you to write it out for me. I see as we go further, x plus 4 is inside there being squared. Does anyone have an idea what that x plus 4 is telling me about the graph in terms of a transformation? Yes?
Shift 4 to the left.
Love it. We'll do this in green. Shift 4 to the left. All that was on the handout that we looked at. Finally, I see a subtract 6 on the end. I'm trying to do that in blue. Who recalls what that subtract 6 maybe tell me to do as I graph?
Should know.
Thank you. Shift, a vertical shift, off vertical. A vertical shift down. Now, if I can take a parent graph and do that to it, oh, by the way, my parent graph, I did an example yesterday, I think I did with a square root graph. Didn't I take a parent graph of a square root, we applied some transformations? Same thing here, except this one's a parabola, not the square root. This is a little bit easier. You guys, here goes. Let's go through the transformations and see what this looks like, because this one leads to something so nice. Let's go to the grid here. Say, Professor, if I see a transformation tomorrow, I will certainly in my directions let you know. Please, first, put the parent graph. I give you partial credit just for the parent graph. The parent graph is a parabola. You said, Professor, can I just make a quick shape? Of course you can. I'm gonna label mine just so I can sort of keep up with it. That's representing that. Now, apply the transformations. The red one says, you guys told me the red one says, reflect that graph across the x-axis. Please tell me, does it now look something like this? And that would be y is equal to, at this point, representing negative out front, x squared. The green, student told me earlier, Professor, shift that graph now, the red graph, 4 to the left. Let's go 4 to the left. And now put this in green, trying to make this look as reasonable as possible. And looks like it might do something like this. You guys agree? I would check out June's notes when she sends them to her. She's much better at this than I am. She is so super neat. Okay, we've got 4 to the left. Now, the last thing is shift it down 6 vertically. Maybe 6 here. And guys, as I shift down that green graph, and I guess we're going to put that in green, not green, got to be blue. So it says, please take this down 6, definitely that point is right there. And see if you guys would agree, does it look something like that for a rough sketch? Would it look something like that? For the final graph. So that blue graph is the graph of all this. That's the graph of the function. I took all these little transformations to get there. So guys, my graph is down here. Let me go ahead and label that point for a reason here. This point should be -4 in terms of coordinates, -6. Now I think some of you guys gave me a name for it. What is that for a parabola, that particular point known as? That's the vertex. Did my final graph open down? Blue graph is opening down, and did that right there tell me earlier it should? There's a negative sign for a coefficient, leading coefficient. It should open down, it's opening down. I have the vertex. Now, believe it or not, that's a rough sketch. Let's do a rough sketch. Believe it or not, this could, I checked it, this blue graph could move over here as it's going down this way. It could move gradually over and intersect that y-axis down there. I see for sure it's not going to touch the x-axis. Not open down. There might be a y-intercept. Let me try to find it right quickly and see if there is. And I'll just identify that right quickly. And a quick way to find the y-intercept is to do what? For the function. Replace x by 0. If I go back, replace x by 0, we end up with this. No problem. Subtract 6. You guys, if I do the math here, that's a -16. Are you kidding? Subtract 6. Wow, there is a y-intercept. It's down at 22. I didn't make a mistake, did I? Did I make a mistake in the arithmetic? So I'm not going to show it, but if this continues to drop down, that's what, move it over a little bit as it drops down, way down here somewhere, it's going to cross over the y-axis at 22. That means this thing must have done something like that and went over and intersected the y-axis. But we know it would do that if I had to do it. There's a y-intercept. Gee, opens down and vertex. Now you said, Professor, I can do one of those. If you ask me to do one of those tomorrow, I can do one of those. Is that true? I can follow the transformations, reflect, and add, and move, and all this business all day. I can do one of those. Looks like that. Now, with that said, ready for another handout here shortly. I might be ready to jump back into the handout you guys have now. Let's see if I'm ready for it. Oh, I am. Okay, section 2.4, it says now sketch the graph of this. Now, guys, I'm going to place it right here, and we're going to sketch the graph of this. F of x is equal to, on your handout, was 2x squared plus 3x subtract 2. Now, watch. Carefully. By the way, this is in chapter 2. I'll tell you more about how much your test covers tomorrow. I don't think we'll go into chapter 2. I'll let you know how much all those topics or sections your test will cover here shortly, before we leave today. Okay, I'd like to graph this. Can anyone in class tell me, is this one, it should graph in a parabola, it's a quadratic, it should be a parabola. By the way, would the parabola open up or down? It all depends on that leading coefficient they call A, because this is a form of, we all know what it looks like, it's ax squared plus bx plus c. In this case, my A is positive, and if it's positive, it should do what? Open up. I gotta graph it. Now tell me, someone in class, I just graphed one for you. I graphed this one. This actually is a quadratic. I graphed it using transformations. Will this one, the way it looks right now, be as easily graphed as that one? If not, what's wrong? Can I graph this one you see right now as easily as I did that one over there, and I did that one over there for a reason? Andrew, tell me.
You have two x's, so wouldn't it be easier if you got it down to one coefficient?
Oh, tell me more.
Well, in that example, it's x plus 4 squared, so that way you can easily see the transformation from right to left.
He's saying, Professor, you don't have this one on the board now that you want to do. You don't have this one in the form like you had here. He says one thing he noticed was this x plus 4 quickly told him there's a horizontal shift to the left. The number on the end says it's a vertical shift down 6. Is that true? I don't have this one in that form. Because they're saying to sketch it. Name the vertex. Name the x-intercept if there are any. Name the y-intercept. This one's just not in that form. Now, did I point out on your handout what must be done here? One of your favorite things in the world to do. To change this in that form that Andrew says I need. What must I apply to this first? I got to complete the square. I've got to use that old process of completion of the square that you saw day 1. Here we are back to it. Now, anyone in class would say, yes, Andrew gets doing, this is a square. X plus 4 quantity squared, there's a square. I'm going to get a square like that here, if I can. Guys, to complete the square, do it in steps as usual. And I think it's best to call this y. Put y here rather than f of x. Easier to work with. Can anyone tell me if I intend to complete the square, even on those that you had to solve equations by completion of the square, what was the first requirement? If you want to complete the square, that was a requirement number 1. What was it?
Coefficient A.
That right there has to be a what? A 1. Watch carefully. That leading coefficient's got to be a 1. Can I change it to a 1? I can, if I do what to the original? Divide by 2. Both sides though. Do it to one side, you gotta do it to the other side. So I'll call step 2 y over 2, and divide everything on the right hand side by 2, and yes, I'll end up with x squared out front for my leading coefficient, 3/2 x in the middle, subtract 1 on the end. That's everything divided by 2. Now I need to start completing the square. Now, can anyone tell me what my next step, because step 3 might be in order for me to go a little further? So I'm not quite there. I gotta find what that square is.
Y equals 0.
Tell me again.
Y equals 0.
No,
Move one,
tell me again.
move one to the other.
Move the 1 to the other side for some reason. She says, Professor, move that 1 over, I get a +1. And I'm going to do this, guys. I think what she wants, PK, she says, Professor, you're ready to do this business that we've done so many times. You're ready to complete the square. After you move that 1 over, in other words, you gotta find that number like you did on my quiz. You gotta find that number to make this thing work, but you gotta add to each side. Now, a quick way to find out what that number is, I think you guys remember, I hope, you take 1/2 of this. Watch my arithmetic here. And you get what, 3/4? And then do what with them? Square it. Put a comma. I think you end up with 9 over 16. That must be placed here and here. Let's see if you guys will agree. Okay. Now, if I'm correct, can anyone tell me, on the right-hand side should now be what we want. All this should be a nice, factored, perfect square. It may look a little strange, but can anyone tell me what it might look like? Over here, it was x plus 4 inside, squared. What is it on this one?
X plus 3/4.
We'll do it again. X, I'll take x plus.
3/4.
Thank you. It's gotta be. It's gotta be. You guys agree? You told me right quick, said, Professor, it's gotta be x plus 3/4 squared. Got that out of the way, guys? That's done on that side. The other side, I have these two numbers that should be put together with a common denominator. So we break it down. Y over 2 plus, and you guys know how to do common denominators. Does anyone know what these two put together with a common denominator of 16? Thank you, I heard it. Think of this as 16 over 16 for the 1. 16 plus 9, was that 25? Over 16. So far, so good? Try my best to make it look like what was given to me on this one directly. I'll make this look the same. More to do with it, yes. I'm gonna move that 25 over 16 over. Wait till you see what's gonna happen here. 25 over 16. And I see one more thing I could do, if my class is following me, which I think you are. Can anyone tell me one more little step, and then I'll have it in the form I need? What do you think has to be done here at this point? To finish it up. Do it again. Multiply everything by 2. You want that y by itself. You want the function by itself. Multiply everything by 2, both sides. 2's will cancel on the left, which I want. Right hand side, of course, 2 times this comes in. And be very careful, I'll in fact put it over here so you can see it. When you multiply that last term by 2, do a little canceling. 2 goes into 16, what, 8? That's 25 over 8. If there's no mistake, I got a few questions about this. Does that, it looks strange with fractions, does that look more like this one over here now? At least the form. I put it in that form. It's called completion of the square. I guarantee you. I doubt not many, probably not anyone, even a professor may not be able to do this. If I just walked down the hallway, I couldn't do it. If I just walked down the hallway and I asked one of my colleagues, what is this? I said, Randy, I'm tired today, I just taught class, grading papers, what are you talking about? Can you give me another name for this? I said, you got 3/4 in there, you got 25 over 8, we multiply all this mess out and clean it up? Yeah, what is it? Who on earth would think that when you clean this mess up, what's that? It's the same as the original. I just changed the original. Guarantee if we had time, we don't have the time. If I should now actually multiply this out, expand this, do that business, multiply by 2, clean it up, collect like terms, go right back to that. It's amazing. They look so different. Now, can anyone tell me, Ramsey, to me, this looks much more pleasant than this. Why on earth would you do that to us? Why would you change this pleasant looking quadratic into this with those awkward looking fractions in it? Why would you do that? Can anyone tell me why I had to do it? Why did I have to change that pleasant looking quadratic? Andrew, tell me.
It matches the form so that we can graph it.
That's exactly right. Exactly right. I'm gonna start graphing here shortly. Guys, I don't see a negative sign out front. Now, I see a 2. Can anyone tell me what really would the effect be if I'm really, really precise on graphing this parabola? What would that 2, what effect would that 2 do you think have on the parabola that we may have just mentioned yesterday on transformations? What effect may that have? I think we just mentioned it real quickly. I think it's going to be a stretch. It'll be a vertical stretch by a factor of 2. If I want to be really, really, really specific, you have to go through and multiply some y coordinates by 2 on that parent graph. Multiply y coordinates by 2 and you'll get a vertical stretch. I'm more concerned about, that would have to know, I'm more concerned about, like Andrew told me, you got that, which is much like that over there, and you got this. Let's see, what else? No negative sign to worry about. Guys, this would tell me what type of a transformation x plus 3/4 inside there being squared. That at least would tell me what type of a transformation here. Here, horizontal shift. Got to put it down here on the bottom, let me know. You can see it. Horizontal shift to the left. Only 3/4 of a unit. That's like that one over there. The other, subtract 25 over 8, that's some awkward numbers to work with. This would tell me what, guys, based on what you saw over there. Thank you, a vertical shift. This one's down. 25 over 8, what is that, 3 1/8? I just do that. So I know the horizontal shift, I know the vertical shift. I guarantee you, maybe someone out there in the universe could do it. I couldn't. If you gave me this, then Ramsey, it's 2x squared plus 3x minus 2. I'll say, yes, what about it? So we'll graph into a parabola, Ramsey. I'll shake my head and nod my head. Of course I knew that. Ramsey, do you know where the vertex is? Oops. Do you know where the turning point on this parabola is, Ramsey? Here, it came out to be this number. Can anyone tell me now at this point, where do you think, I don't have a graph yet, where do you think the turning point for this parabola, by the way, this parabola is going to be opening up. Where's the turning point called the vertex located now since I have changed its form? Go for it.
Minus 3/4.
Hang on now. Vertex, let's call it vertex. And it's ordered pair, tell me again, what is it?
Minus 3/4.
Love it. Students will tell me it's a horizontal shift to the left. So you have to represent the coordinates negative, you move to the left, negative 3/4. And what else?
Negative 25 is.
Love it. That's my vertical shift. Wouldn't it be nice? I'm gonna finish this up here shortly. Wouldn't it have been nice if I had been smart enough to have known what he just gave me for the vertex? This is my turning point when I get to the graph. Wouldn't it have been nice if I could have recognized this immediately up here in that pleasant form and not have to go through all this? Wouldn't it have been nice not to have gone through that completion of the square, which took so much time? And sometimes you'll add the wrong number on each side and you'll mess it up. Wouldn't it have been nice to say, wait, Professor, can't you just stick with that nice little pleasant form for me? Is there a way for Professor, that I can go directly to this, and not do this? Wouldn't that be nice?
Yes.
That's the way. That's the way you don't have to touch completion of the square. Now, I'm not gonna ask you to complete the square when you probably see this on the quiz or anything, of course. But also I'm gonna ask you to do a few, the quick way. I'm gonna show you the quick way on this trip here. There's a quick way to find this vertex. And I'll do that, all that business. Hold off on that though. By the way, so I take questions here, I think I saw a hand go up. This vertex turning point, this parabola opens up. I'm gonna use a word here. If it opens up, I don't have the graph yet. It's gonna do something like this. That one over there opened down. So my vertex that he just gave me is right here. That's this. Could I also identify that, there's another connection to a lesson. Could I also identify that point, not only a vertex, is it a minimum point? Is it the absolute minimum on that graph? Now I know the minimum of the graph, the minimum of the function, if I know the vertex. In fact, I could call it in this case local and absolute. The definitely is an absolute. That's the lowest point of all. And what is it? And negative 25/8 is the furthest it drops down. So this function up here, I don't care what you replace x by, I've got 30 students. If I had the time, which we don't, and I start with student number 1, I would say student number 1, replace x by any number you wish. He would do it for me, say, Professor, I got this answer. I go to student number 2, I say, now use a different number than he did, use a different number, plug it in here, and tell me what you get. The student will do it for me. I go all the way around with different numbers. And finally get to Mr. Park back there, I say, Mr. Park, put this number in, different number, crunch it out, get a result. Guarantee you, when I collect all those results that came out after you plugged into your particular x, there will not be, for an answer, anything lower than negative 3 1/8. That's the lowest the graph goes. That's the minimum. If someone would turn in their paper and say, Professor, I got 0 for that little exercise, I didn't get my point. What happened? Because you plugged in the number wrong and did arithmetic wrong, and you gave me an answer of -6. The lowest it can go is negative 3 1/8. So I know, I don't want to check your arithmetic, I know you're wrong. You cannot get a -6 to come out. Unless you plugged in your X number replacement incorrectly some way. The lowest is negative 3 1/8. What's that question?
I was just thinking, so the graph is either like, its change of rate is either increasing or decreasing, but at the vertex is 0. So basically just put the change of rate equal to 0, and that will be the vertex.
You're doing calculus. You know a little bit about calculus then. And you just told me, we're not going to apply calculus, so I think it's not tempting for me to show you a shorter way than this. Much shorter way. He's thinking about calculus here. He says, Professor, one thing I noticed from calculus, on this particular parabola here, on the left of this vertex, my graph, if you go from left to right, my graph is decreasing, it's falling. This piece is falling. Then it hits the vertex, levels off, and then it picks up on the other side, and it does what? It increases, it rises. I think we talked about decreasing and increasing here on graphs. So this side is decreasing, the other side in green is increasing, and then that point in between is called the vertex. He says, does that always happen? It does. There's going to be a change at the vertex from one side to the other. And in fact, he told me right here, at this vertex itself, nothing's happening. It's just stationary. In fact, I think you said something like it's like 0. Like the slope or the average rate of change is 0. You brought in the average rate of change with this. You could. You could calculate it all. Guys, make sense? Now, watch my time here. I'm getting excited about this. Very excited about this. Here's the issue. When you see this, and I'm thinking about the future quiz that may have this on it. that would be the radius. That would be worth 10 points, just one problem. And what would that problem be? I'd give the function to you, and then ask you to complete the square, get this, and then name the vertex, and then go to the side and graph it. We don't have to quite graph it yet. Graph it with some other details, and that would be the 10 points. Guys, any concerns about the completion of the square? Andrew, you really helped me out today. He says, Professor, you're looking for this form here. That's what I did. I put that over there in the form that this was given at the beginning, and therefore now I'm graphing. Guys, any concerns here on this? Okay, let me erase a little bit. I've got something for you guys to do. Here we go. Let's make this look as reasonable as possible. So proud of you guys to do this in 6 weeks. You do this course in 6 weeks, 16 weeks of work in 6. That's what we're doing. Okay, vertex, let me put the vertex on there right now. And we found with some help here, -3/4 down 6 and 1/8. Guys, let me mark 1 here and down, oh boy, 3 and 1/8. Mark it like this, get an idea. And we put that vertex in a different color so we can keep track of it. Okay, I'll -3/4, close to, -3/4, act together here. -3/4, yes. -1 there. Okay, -3/4 down, 3 and 1/8. Guys, I'm gonna place it somewhere right in there. Be there for vertex, that's my turning point. -3/4 down, 3 and 1/8. Did you guys see that? Okay, it should open up. So if I were a student, say, well, Professor, my goodness, you know where the turning point is, vertex, just go ahead and make it open up. Do this and I'm finished. What do you think I'm gonna ask you to do before you actually open it up and have the complete parabola? What's missing in that?
Showing the transformation.
Oh, yeah, look at this, look at this. Beautiful. I went through all the transformations like he said on this one, didn't I? I showed every transformation. This one, I'm hoping after all this work we had to go through, I'm hoping maybe, hang on, we got the vertex from the transformations down here. I'm hoping now maybe I can just recognize other items and just graph it. What other items may help me to get the graph done fairly quickly now, since I've already gone through this other work. Andrew, what you said was perfect. The one I gave you at the beginning was, I had to do transformations on it. This one, I'm gonna just quickly do it, since it requires some work here. I'm going to identify the vertex, I plotted it. Now, what else could I plot that may help me say, Professor, just get it done? You don't have to go through all those transformations on this one. What else would help? Yes.
Like the parts where y equals 0.
Oh, called it what, the X and Y intercepts?
Yeah.
So rather than just saying, oh, Professor, gotta just do this, make it open up, touch here, go back up. Well, you could, but I'd like to know, as you do that, does it cross the Y-axis somewhere? Does it cross the X-axis somewhere? Definitely it does. I need to find those. Then I'll finish it up. Okay, let's find the X-intercept first, guys. Put it in here. X-intercept, set the Y equal to 0. Now I'm gonna go back to the original. Oh, this is a beautiful problem. Now, I think, to save me a little time, I think this one will factor. To avoid the quadratic formula, even though the quadratic formula would always work, but I think to save me a little time, you guys can watch and make sure I do it correctly. It's 2x plus 2 minus 1. Let me step back and see if you guys agree. Does it factor? Are those the factors? We can factor it, do it by quadratic formula. Split this up. I'm looking at x equals 1/2 and x is equal to a -2. I prefer at this point, I wouldn't count it wrong if you left it like that, but I prefer it written like this, as ordered pairs, since I'm talking about x-intercepts. Erase this. Okay, now I know my x-intercepts are, if that's correct, 1/2, place 1/2 right here, and put it in blue. 1/2 right here. Make sure we see it. And -2 over here on the side is here. Y-intercept would help before I finally get the graph and find the y-intercept. I think the student told me earlier. It would be easier than trying to find the x. Let's go back and replace all the x's by 0. In other words, you find f of 0. I'll show every student that just in case you've forgotten. Guys, I think you end up with a -2. So we'll write this as an ordered pair. Since this is a y-intercept, it's written like this. I prefer that. So that says drop down to a -2. Set in green. The y-intercept's right here. Now, is that enough to connect and get a parabola connecting those points? Open it up. Can I say now the graph might look, a basic graph may look something like this. Swoops down, picks that up, goes down to the vertex. Turns, goes back up. Is that the graph? Am I done? Am I finished? Okay, and I did not touch on this one transformations. Did not touch transformations. I've already erased all my work in there. Oh, by the way, wasn't there a horizontal shift of some sort, what, 3/4 to the right? Wasn't that involved on this somehow, 3/4 to the, 3/4 to the right? Check and see, that form, I erased the form. Was it 3/4 to the right, x minus 3/4 squared, was that x minus 3/4 squared? Oh, it's plus? Oh, it's 3/4 to the left. So there's a horizontal shift 3/4 to the left. I didn't do that. I didn't do it by transformation, did I? No. So Andrew, you're right. So in my directions, if I say to sketch, and first I'll ask you to put it in this form. You can just go ahead and do it after you put it in that form. If I say no, I'll give the form to you, now use transformations. Okay? So this will be done quickly. There's the graph. Done. Yes?
I thought there was like the horizontal strap.
Ah, beautiful, beautiful. Here goes, here goes, here goes. You're saying, Professor, was there a 2 involved here, guys? A 2 out front, and that would be a vertical what? Stretch by a factor of what? 2. If you really want to get the effect of that, I'm going to accept that graph right there as my final answer. But if you really, really, really want to bring in the 2 out front, what do you think I would have to do to sort of get the effect that this should be compared to the parent graph, a stretch by a factor of 2? Because here's my parent graph. What do you think a factor of 2 would do to that graph? Because there was a 2 involved, I didn't do it here on this one, I'm going to accept this for my answer. What do you think that factor of 2 out front, vertical stretch by a factor of 2, what would you have to do? I'm going to do it on the parent graph, just to show the effect. Okay? What do you think I would have to do short of stretch by a factor of 2 on this, the black parent graph? Let's go back to it. I'm glad you brought my attention to it. Anyone? What do you think I'm going to do? Not vertical shift, vertical stretch. Go for it.
I will multiply it with the y coordinate.
You got to multiply the y coordinates by 2. So that means you have to go to that parent graph. I'm not going to do it over there on that one. You have to go to the parent graph and say, Professor, you mean I've got to find a few points on here and do what you just suggested? Well, of course, you have to go to 0, 0. That's a nice one to work with. I'll put it down here. I think 1, 1. How do I know 1, 1's on there? Because if I replace x by 1, I square to get 1. So it's on the parent graph. A -1 out here 1 is definitely on that parent graph. 2, 4, I could try 2, 4. Negative 2, 4. 3, 9. Negative 3, 9. Is that true? So let's try it on these few. Now what did he tell me to do? He says, Professor, multiply the y coordinates, the y, for a vertical stretch, by 2. Okay, that means this point right here, 2 times 0, that's my y coordinate, stays right where it is. No change there. Put that in, this in the blue. So that point stays right where it is. When I reach this point, now it says 1, 1. If you want to see a vertical stretch, you gotta multiply that y coordinate 1 by 2. Now where is it?
1, 2.
Yeah, you want to go out 1, up what? 2. It's right in there. Next one I had what? Negative 1 up 1? Now where's it? So multiply the y coordinate by 2. Is it negative 1 up 2? So it's somewhere in here. Looks like my blue graph, my blue there points to like the black here. Does it now do something like this? If I connect. That's what a vertical stretch would do to my graph. Okay, so this graph right here that I have here might be in here somewhere. Doing the same thing though. But I'm going to accept this as my final graph. And you brought that to my attention. Vertical stretch by a factor of 2. Got any concerns? No. Now, someone tell me before I finish up and take a break here, I knew it was going to take a long time on this. Did I have a few questions at the end of the handout about this function? I think I did. Okay. Arena, you're close by. Could you read the questions there at the bottom? What's it asking for? Yeah, then the vertex, we did the vertex, so hang on now. So number 1, the vertex was, oh boy, I erased it here, where was it, or did I? Was it negative 3/4? Was it negative 3/4? And negative what, 25 over 8?
Yes.
I think. Because I give you points for all this, we can see a quiz on this. That's my vertex. Tell me more.
Name the x and y intercept.
Oh, x and y intercept, we already had it. The x-intercept were, we found those earlier. And I'll label that, Mr. Parkway, sorry. 1/2, 0, and a negative 2, 0. The y-intercept, we did that earlier, was 0, negative 2, I think it was. We did those. What's next?
Domain and
Ah, beautiful. Guys, the domain of this graph, if you look at the graph itself from left to right,
Minus something.
yeah, it's everything. Be careful of the range though. The range is the up and down. How far down does that graph drop? I think it was negative, where's the negative 25 over 8, is that the lowest?
Yeah.
And it rises forever. How would that be expressed in integral notation?
Minus 25, please.
Bracket,
Till infinity.
negative 25 over 8, I'm hearing, through infinity. That is our range. Domain's everything. What's next?
intervals in which f of x is more than 0.
Okay, hang on now. Number 4 says, can you name the intervals on this where this is true? F of x, the function, must be constant. Now, can you look at the graph and tell me, based on the graph, where am I guaranteed? What x's can I put in here guaranteed, up here, to make this result come out to be a positive? Where you answer it at random. I'm just throwing a number at you because the domain's all real numbers, isn't it? It's going to work. I'm going to throw a 0 in. If I throw a 0 in here and do the calculations, negative 2. So I know 0 is not part of the answer because she wants to know when is the result greater than 0. What positive? If I put a 1 in there, just at random, I put a 1, I get 2 plus 3 is 5, 5 subtract 2 is 3. Would 3 satisfy this? Yes, 3 is greater than 0. So I like to know what numbers will work and what numbers will not, and tell me an interval notation, and based on the graph would help. Go for it.
Negative infinity to negative 2.
Now, hang on just 1 second. Now, why would you say that? I'm going to shade this in. Tell us last why you're saying this will help me answer the question.
It's x-intercept.
Okay, so it's above the x-axis. It's that little piece right there above the x-axis, which indicates positive. And that's what she wants. She wants positive. Is there another piece?
1/2 to infinity.
Why? Because that piece also is above the x-axis. So if you're above the x-axis, that indicates that's what you want. Those are positive results. In integral notation, I think you were telling me like negative infinity out to what was it, -2?
Yes.
And then union, I think it was what, 1/2? For infinity. Nice. Now, I'm not going to just stand here and randomly put a 0 in, put a 1 in, put a 4 in, see what numbers work. Now I know for sure, Andrew, if I really want to satisfy what she asked, I've got to select a number either in this interval and put it in up here, and I'm guaranteed you'll get a positive answer. If you put anything in here, any number you wish in this interval, and there's an infinite number of numbers, put them in here, guarantee you'll get a positive answer. You get outside this and put it in, you'll get a negative answer. She wanted positive. That's what that means. What else was there?
Here's the value of the maximum.
There you go. Number 5 says, now before we close down, take a well-deserved break here shortly here. Number 5 says, Professor, they want you now to name the maximum or the minimum on this. My guys, does this one have a minimum? We discussed that. So the minimum value, I think we discussed this earlier, it drops down to, for a minimum, I think it's what was it, -25/8. -3 1/8. That's what they want. How far down does it drop for a minimum? Done. Okay. Oh, that's it. Jeez. Jeez. Now we're gonna take a break. Let me ask so. This is kind of after the break, so think about it during your break. I'm sure you will. Think about it. Ramsey, is there another way without this? Without that completion of the square that our race, which you know that completion of the square is so messy at times. Professor, is there another way to find that minimum or maximum value, vertex in other words, and not do it either way as you've done it right now? There it is. After the break, you'll be able to find this right here. Vertex, right here. You'll be able to find the vertex for me in seconds. You'll be able to find the vertex within seconds. And I'll have to touch completion square. Has anyone seen it? You. That's what's coming up after. Do it in seconds to find this. Guys, do we have a quiz tonight? I thought we had a quiz.
Yesterday, an exam tomorrow.
Same tomorrow. I thought we had another quiz, and maybe on Saturday another quiz. Are we meeting on Saturday? We are, aren't we? No? I think the fires are sort of dying off. Maybe we could get together and have a party at the beach or something. Talk about that. Okay, guys, take your well-deserved 15-minute break. And that short cut here shortly. I'll get your quizzes back to you after the break.
아, 그래요?